Okay. Hi, students. Today, let me discuss about the series LCR circuit. In the board exams, normally they are asking derive the expression for impedance in LCR circuit, expression for current in the LCR circuit, what is a phase angle, phase lead, phase lag, like that. Okay, ಮಕ್ಕಳು ಅರ್ಥವಾಯ್ತಲ್ಲ? ಇವಾಗ ಒಂದು ಡೆರಿವೇಶನ್ ಮಾಡ್ತಾನೆ. That is called impedance. Derivation for impedance in series LCR circuit. Here L stands for inductance, C stands for capacitance, and R stands for resistance. Okay. ಹಂಗಿದ್ರೆ ಪ್ರಶ್ನೆ ಹೆಂಗ್ ಕೇಳ್ತಾರೆ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ ಅಲ್ಲಿ? Let me write that question. Okay. The question, it looks like this. See, derive an expression for impedance in the series LCR circuit and also current and phase angle. Okay, Makla, this is the question. See, derive an expression for impedance in the series LCR circuit and also current and phase angle. Idu nimige 5 marks alli keltare makla. So it carries 5 marks in your board exams. Okay. Now let us derive that equation. Okay, ನಿಮಗೆ ಬೋರ್ಡ್ ಎಕ್ಸಾಮ್ಗೆ ನಾವು ಏನು ಕೇಳ್ತೀವಿ ಅದನ್ನ ಇಲ್ಲಿ ಬರೆಯೋಣ. ಫೈನ್. ಸೊ ಇದಕ್ಕೆ ಫಸ್ಟ್ ಏನು ತಗೋಬೇಕು ಅಂತಂದ್ರೆ we have to consider inductance coil of inductance L, capacitor of capacitance C, a resistor of resistance R connected in series shown in this figure. ನೋಡಿ ಇದಕ್ಕೆ ನಿಮ್ಮ ಆನ್ಸರ್ ಇಷ್ಟಿರಬೇಕು. ನೋಡಿ ಫಸ್ಟ್ ಡಯಾಗ್ರಾಮ್ ಕರೆಕ್ಟಾ? ಮತ್ತೆ ಅಂದ್ರೆ ಇಲ್ಲಿ say look at this, there is one more addition to this question using phasor diagram method. Okay, using phasor diagram method ಇದನ್ನು ನಿಮಗೆ ಕೇಳ್ತಾರೆ. ಓಕೆ, ಸೊ ನಿಮಗೆ ಪ್ರೀವಿಯಸ್ ಕ್ಲಾಸಸ್ ಅಲ್ಲಿ ಇದು ಗೊತ್ತಿರುತ್ತೆ. ಇನ್ ಕೇಸ್ ಆಫ್ an LCR circuit, in case of a pure inductance, voltage leads current by pi/2 radian. In case of pure capacitance, voltage lags current by pi/2 radian. And in case of pure resistance, voltage and current are in the same phase. ಅದು ನಿಮಗೆ ಐಡಿಯಾ ಇರಬೇಕು, ಆಯ್ತಾ? ಅದನ್ನ ಕೀಪಿಂಗ್ ದಟ್ ಇನ್ ಮೈಂಡ್, let me derive this equation. So for that purpose, let us consider an inductor of inductance L. Look at this. Inductance L. ನೋಡಿ ಇದನ್ನ ಹಿಂಗ್ ಬರಿಬೇಕು. Capacitor of capacitance C ಹಿಂಗ್ ಬರಿಬೇಕು. Resistor of resistance R ಹಿಂಗ್ ಬರಿಬೇಕು. ನೋಡಿ ಮಕ್ಕಳು, ಇಂಡಕ್ಟೆನ್ಸ್ ನ ಎಲ್ ಅಂತ ಕರೀತಾರೆ, ಕೆಪಾಸಿಟೆನ್ಸ್ ನ ಸಿ ಅಂತ ಕರಿತೀವಿ, ರೆಸಿಸ್ಟೆನ್ಸ್ ನ ಆರ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ ದೇ ಆರ್ ಆಲ್ ಕನೆಕ್ಟೆಡ್ ಇನ್ series shown in figure. Now this series combination is connected across an AC source. Look at that. This is an AC source like this. Okay. So connected in series, LCR. That's why it is called LCR circuit and kariತಾರೆ. Okay. ನೋಡಿ ಇಲ್ಲಿ ಬರೀತೀನಿ. Consider an inductance L capacitance C and resistance capital R connected in series across an AC source shown in figure. Okay, ಮಕ್ಕಳ ನೋಡಿ ಇದು ಆಲ್ರೆಡಿ ನೋಡಿದ್ದೀರಾ ನೀವು. See, consider an inductance L, capacitance C and resistance R connected in series across an AC source shown in figure. ಇಷ್ಟೆಲ್ಲ ಇದಾದ್ಮೇಲೆ ಇವಾಗ ನೋಡಿ let XL ಅಂದ್ರೆ ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್. ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್. XC ಅಂದ್ರೆ ಕೆಪಾಸಿಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್. I means current in the circuit. V applied voltage. Okay. VL potential difference PD across L inductance. VC ಅಂದ್ರೆ potential difference across C capacitance. VR ಅಂತಂದ್ರೆ potential difference across R. ಓಕೆ ಮಕ್ಕಳು ನೋಡಿ ಇಷ್ಟನ್ನ ನೀವು ಬರ್ಕೋಬೇಕು. ಲೆಟ್ XL ಅಂದ್ರೆ ಏನು? ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್. XC ಅಂದ್ರೆ ಕೆಪಾಸಿಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್. I stands for current in the circuit. V stands for applied voltage. VL ಅಂದ್ರೆ PD across L. VC stands for PD across C. VR indicates potential difference across R. Okay, one thing you should remember, since they are in series, current is same in all the cases, correct? So ಇಲ್ಲಿ ಬೇಕಾದ್ರೆ ಬರೀತೀನಿ. Since L, C and R are in series, current I is same. Current I is same through all components. Okay, ಸೇಮ್ ಇರುತ್ತೆ ಅಂತ ಅಂದ್ರೆ ಇಂಡಕ್ಟೆನ್ಸ್ ಕರೆಂಟ್ ಎಷ್ಟಿರುತ್ತೋ CL ಕೂಡ ಅಷ್ಟೇ ಇರುತ್ತೆ, RL ಕೂಡ ಅಷ್ಟೇ ಇರುತ್ತೆ. ಸೊ ಫ್ರಮ್ ಓಮ್ಸ್ ಲಾ ಬರೀತೀನಿ ಏನಂತ. ಫ್ರಮ್ ಓಮ್ಸ್ ಲಾ ಏನ್ ಬರೀಬಹುದು ನೋಡಿ. VL is equal to I into XL. VC is equal to I into XC. VR is equal to I into R. VL is I into XL. VC is I into XC. VR is equal to I into R. Okay, from Ohm's law, V is equal to I into R law. Inductance, it is called inductive reactance. In case of capacitance, it should be capacitive reactance. In case of R, it is R only, R. Okay. Let us assume inductive reactance is greater than capacitive reactance. Let us assume XL is greater than XC anta itkoona. Okay, fine. So keeping all this in your mind, so let me explain how the phase diagram is constructed. Okay, now let us explain the phasor diagram. ನೋಡಿ ನಿಮಗೆ ಗೊತ್ತಿರಲಿ ಮಕ್ಕಳ, ಇಲ್ಲಿ ಆಲ್ರೆಡಿ ನಿಮಗೆ ಇಷ್ಟೆಲ್ಲ ಗೊತ್ತಿರಲಿ, ಇವೆಲ್ಲ ನೋಡಿ ಇಷ್ಟೆಲ್ಲ ಕೂಡ ಬ್ರೀಫ್ ಆಗಿ ಬರೀಬೇಕು. ಸರ್ಕ್ಯೂಟ್ ಡಯಾಗ್ರಾಮ್, ಸರ್ಕ್ಯೂಟ್ ಎಕ್ಸ್ಪ್ಲನೇಷನ್, ಟರ್ಮಿನಾಲಜಿ. ಸೊ ಕರೆಂಟ್ ಸೇಮ್ ಇರುತ್ತೆ ಬಿಕಾಸ್ ದೇ ಆರ್ ಇನ್ ಸೀರೀಸ್. From Ohm's law, VL is equal to IXL, VC is equal to IXC, VR is equal to IR. Let us assume XL is greater than XC. It is an inductive dominated circuit. Let us assume like that. Okay, let us construct the phasor diagram. Okay, makla. Illi nanu, for example, ivaga illi barittene. Idu phasor diagram. Let us say this is, this vector represents VR and this vector represents I. Let us say this is the point O anta itkoli. So in case of resistance, you know well, current and voltage are in the same phase. Hagagi itra barda. Okay, now let us say in case of inductance, voltage leads current. So current is along x-axis. Voltage leads current andre heng baribeku antandre nodi ee tara baribeku. Nodi like this. Ee tara baribeku. Correct? So idanna nanu ee tara baradu bittu idanna VL anta karitini. VL. You know well because it is inductive. In the case of inductance, voltage leads current by pi by 2. So illi vector barittine matte. And in the case of capacitance, voltage lags current. Lagging andre hindugade baribeku. So voltage lags current andre I can say like this. Nodi ee tara baribeku. Like this. Okay, makla. So this is VC anta barittini. VC. So I will write down this. This is O, this is A, this is B, this is C, this is D. Let us call these vectors. Okay, fine. Ivaga diagram alli ella explain madidini. Ivaga VL is greater than VC because alli barittini nodi, since XL is greater than XC, VL should be greater than VC. Therefore, correct? Agagi vector OC is greater than OD. Therefore, OC is greater than OD anta baribeku. Okay, makla. Ivaga. So in the diagram, vector OA, in the figure, il bekara barittini. In figure, vector OB represents VR. Vector OA represents I. Vector OC represents VL. Vector OD represents VC. Okay, makla. So since VL is greater than VC, resultant of VL and VC is ಇಲ್ಲಿ ಬರೀತೀನಿ. This is a representation. ನೋಡಿ ಇದನ್ನ E ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ನೋಡಿ vector OE. Vector OE is equal to VL minus VC. See, vector OE andre VL minus VC ಅಂತ ಬರ್ಕೋಬಹುದು like this. Now, so resultant of VL and VC is VL minus VC. Now let us construct one rectangle like this. ನೋಡಿ ಈ ತರ ಬರೀತೀನಿ ಇಲ್ಲಿಂದ like this. ನೋಡಿ like this. ನೋಡಿ ಆಯ್ತಾ? So OE ಇದನ್ನು F ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. Look at that. So ಇವಾಗ draw diagonal OF. Draw diagonal OF. ಬರೀತೀನಿ ನೋಡಿ like this. Okay. So this is the diagonal. So this represents the resultant voltage VR. Sorry, V only. Okay. So this is called phasor diagram. Let the resultant voltage leads current by some angle phi ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. ಅರ್ಥ ಮಾಡ್ಕೊಳ್ಳಿದಲ್ಲ. So in the phasor diagram, you can observe all the things. The vectors in the figure, vector OB represents VR, OA represents I, OC represents VL, OD represents VC, OE represents VL minus VC, and OF, you can say, OF, vector OF represents the resultant voltage V. This is called resultant voltage. Resultant voltage. Okay, makla? ಇಷ್ಟನ್ನ ಐಡ್ ಇಟ್ಕೋಬೇಕು. ಇದನ್ನೇ ನಾವು ಫೇಸರ್ ಡಯಾಗ್ರಾಮ್ ಅಂತ ಬರೀಬೇಕು. ಸೊ ಆರೋ ಮಾರ್ಕ್ ಕರೆಕ್ಟ್ ಆಗಿ ಇರಬೇಕು ಇಲ್ಲಿ. Everything should be clear. Okay, makla. After writing this phasor diagram, now by using this phasor diagram, let us find out what is called OF or V. See, from phasor diagram ಅಂತ ಬರೀತೀನಿ. From phasor diagram, ನೋಡಿ from phasor diagram ಏನು ಹೇಳಬಹುದು? From right angle triangle OFA ಅಥವಾ OAF. ನೋಡಿ from phasor diagram, from triangle OAF. Is it correct? OAF. We can write OF square is equal to, look at that. OF square is equal to OA square plus FA square. OA square plus FA square. Okay, makla? From Pythagoras theorem. So from this I can write what is called OF? V square. V. What is called OA? It is called VR square. Plus what is called FA? FA nothing but EO. FA nothing but EO. That is nothing but VL minus VC whole square. Okay, because FA is equal to, from diagram, FA is equal to OE, alva? OE is equal to VL minus VC. So V square is equal to VR square plus VL minus VC whole square. So I want V beko. V is equal to square root of VR square plus VL minus VC whole square. Okay, makla? So this is the resultant voltage across series combination. The resultant voltage. So this equation represents, okay, this equation represents what? A resultant voltage. Okay. Now we know this. What is called VR? VR is called potential difference across resistance. VR is equal to I into R. What is VL? Potential difference across inductance. We can write VL is equal to I into XL. What is VC? Potential difference across capacitance. How can we write? VC is equal to I into XC. Now let us substitute that. V is equal to also V is equal to under root. What is VR? I into R whole square plus what is VL? I into XL. What is VC? I into XC whole square. Okay, Makla? You should write down correctly. Next step, V is equal to under root IR whole square means it is I square R square plus here IXL minus IXC whole square ಇದೆ ಅಲ್ಲಿ I common ತೆಗೆದುಬಿಟ್ರೆ power 2 ಎರಡಕ್ಕೂ ಬರುತ್ತೆ ಹಾಗಾಗಿ I can write down as I square into XL minus XC whole square. Like this you can write. Okay. Next step, V is equal to, so you can take out I square common. Root of I square is I. Root of I square is I into root of, see, R square plus XL minus XC whole square. Look at this. Okay, now I can rearrange like this. So V is equal to I into Z, where Z is equal to root of R square plus XL minus XC whole square, called impedance. Called impedance in the circuit. Okay, ಮಕ್ಕಳು ಅರ್ಥವಾಯ್ತೇನ್ರು? So compare ಮಾಡಿ, V is equal to I into Z ಅಂತ ಬರೆದಾಗ. So Z is called impedance ಅಂತ ಕರೀತಾನೆ, just equivalent to resistance ಅದು. But I use a word impedance in case of inductance, capacitance, resistance connected across AC source. Okay, so Z stands for opposition to the flow of AC. That's it. So I can define Z later on. So Z is equal to root of R square plus XL minus XC whole square. So that is the equation for impedance. Or we can find current. See, also current I in the circuit is, I can write like this. See, I is equal to V by Z, or I can say V by root of R square plus XL minus XC whole square. Look at this. So from this equation we can find out what is the current in the circuit. Okay, makla? So ಇದನ್ನ ನೀವು ಇಷ್ಟನ derivation ಮಾಡಬೇಕು. At the same time, ನೋಡಿ, we got V value, we got impedance value. So also we can find out phase lead. See, look at this diagram. See, in this case, I assume VL greater than VC because XL is greater than XC. Therefore, voltage leads current by some angle phi. From right angle triangle OAF, to find phase angle. See, to find phase angle. ಇದನ್ನು ಬೇಕಾದ್ರೆ phase lead ಅಂತ ಕರೀತಾರೆ. Phase lead because voltage is leading. ಹಂಗಿದ್ರೆ from diagram, from figure, from triangle, look at this, from triangle OAF, from triangle OAF in ಬರಿಬಹುದು tan phi is equal to, look at this, opposite side by adjacent side, FA by OA, FA divided by OA. ಕರೆಕ್ಟಾ? ಅಥವಾ tan phi is equal to what is FA? VL minus VC. What is OA? VR. ನೋಡಿ, if you know VL, VC, VR, we can find tan phi. ಆಯ್ತಾ? At the same time, ನೋಡಿ, also tan phi is equal to what is VL? I into XL minus what is VC? I into XC divided by what is VR? I into R. Now, ಇವಾಗ I cancel ಆಗುತ್ತೆ. Tan phi is equal to I cancel ಆಗಿಬಿಡುತ್ತೆ. Tan phi is equal to remaining is XL minus XC by R. ಯಾಕಂದ್ರೆ ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲಿ I cancel ಆಗುತ್ತೆ. I ಕಾಮನ್ ತೆಗಿತೀರಾ, ಡಿನಾಮಿನೇಟರ್ I ಇದೆ. It can be take note. So like this, ಇಲ್ಲಿ ಬರೆದಿರ್ತೀವಿ ನೋಡಿ. So I ಬರೆದ್ಬಿಟ್ಟು XL minus XC by I into R. Okay, this I and this I get cancelled. So this is an equation for phase lead, XL minus XC by R. Or else I can write like this: phi is equal to tan inverse XL minus XC by R. See, this is the expression for phase lead in LCR circuit. Okay, ಮಕ್ಕಳ ಇದನ್ನ ತುಂಬಾ ಚೆನ್ನಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೋಬೇಕು. ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೂಡ ಬರುತ್ತೆ ಇದರಲ್ಲಿ. Okay, hope you understood. ನೋಡಿ, from this equation, from this discussion, we arrived all the things. Hope you understood. ಇದನ್ನು ನೀವು ಪ್ರಾಕ್ಟೀಸ್ ಮಾಡಿ, you will get 5 marks in PUC board exams. So this is circuit diagram, this is phasor diagram. ನೋಡಿ, ಇದು phasor diagram. ಈ phasor diagram ಅಲ್ಲಿ ನೋಡಿ, derivation for impedance Z ಗೊತ್ತಾಯ್ತು, derivation for current ಗೊತ್ತಾಯ್ತು, equation for phase angle ಗೊತ್ತಾಯ್ತು. ನೋಡಿ, phase angle ಇಷ್ಟು ಪೂರ್ತಿಯಾಗಿ ನಿಮಗೆ you may get around 5 marks. ಆಯ್ತಾ? So ಇವಾಗ now let us define what is called impedance. ನೋಡಿ, definition ಇಲ್ಲಿ ಕೇಳಬಹುದು ನಿಮಗೆ, what is impedance? ನೋಡಿ, what is impedance Z? ಸೊ ಇದನ್ನ ಹೇಳ್ಬೋದು. ನೋಡಿ, impedance ಅಂದ್ರೆ ಏನು? It is the effective opposition offered by the inductance, capacitance and resistance to the flow of AC. ಬರೀಬೋದಲ್ವಾ? ನೋಡಿ, it is effective opposition. It is effective opposition. It is effective opposition offered by inductance, capacitance and resistance to the flow of AC. It is effective opposition offered by the inductance, capacitance and resistance to the flow of AC. ಅದನ್ನ Z ಅಂತ ಕರೀತಾರೆ. ಆಯ್ತಾ? ಆರ್ ಇನ್ನೊಂದ್ ತರ ಹೇಳ್ಬೋದು, ಏನಂತಂದ್ರೆ ರೇಷಿಯೋ ಆಫ್ RMS value of voltage and RMS value of current. Ratio of RMS value of voltage and RMS value of current is also called impedance, denoted by Z. I can say, therefore, Z is equal to V by I, or it is VRMS by IRMS. ಮಕ್ಕಳ ಇದನ್ನ ಚೆನ್ನಾಗಿ ನೆನ್ಪಿಟ್ಕೊಡಿ. ಸೊ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೇಳಬಹುದು, ಕರೆಂಟ್ ಕೇಳಬಹುದು, ಅವಾಗ Z ಮಾಡ್ಕೋಬೇಕು. Z ಮಾಡ್ಕೊಂಡ್ಮೇಲೆ ವಿ ಕ್ಯಾನ್ ಫೈಂಡ್ ಔಟ್ ಕರೆಂಟ್. ಸಿ ಕರೆಂಟ್, ಇವಾಗ ಕರೆಂಟ್ ಬೇಕು ಅನ್ಕೊಳ್ಳಿ, ಕರೆಂಟ್ ವಿ ಕ್ಯಾನ್ ಫೈಂಡ್ ಔಟ್. ಸಿ IRMS is equal to VRMS by Z. ನೋಡಿ, ಇದು ಕೂಡ ನಾವು ಹೇಳ್ಬೋದು. ಸೊ ಪ್ರಾಬ್ಲಮ್ಸ್ ಅಲ್ಲಿ ಕೇಳಬಹುದು. ಸೊ Z we have to find out, VRMS ಕೊಟ್ಟಿರ್ತೀನಿ, and IRMS you can find out so many ampere. ಆಯ್ತಾ? ಸೊ ಆಫ್ಟರ್ ಫೈಂಡಿಂಗ್ IRMS we can also find out ಮೀನ್ ವ್ಯಾಲ್ಯೂ ಕೂಡ ಮಾಡಬಹುದು. ಆಯ್ತಾ? ಮೀನ್ ವ್ಯಾಲ್ಯೂ ಹೆಂಗ್ ಮಾಡ್ತೀರಾ? ಮೀನ್ ವ್ಯಾಲ್ಯೂ ವಿ ಹ್ಯಾವ್ ದಿಸ್ ಈಕ್ವೇಶನ್. ಏನು ವಿ ಹ್ಯಾವ್ ನೋಡಿ V0 ಮಾಡ್ತೀರಾ ನೋಡಿ. ಸಿ IRMS is equal to I0 by root 2. Therefore, I0 is equal to root 2 into IRMS. Okay, makla? Peak value bantu. So, peak value bandmele, we have mean value of AC. Nodi, I average, atho IM ant karitare, atho I average andru karitare. I average is equal to 2 by pi into I0. ಮೇಲ್ಗಡೆ I0 ಮಾಡಿರ್ತೀರಿ, ಆಯ್ತಾ? 2 by pi into I0 ಮಾಡ್ಕೊಂಡ್ಬಿಟ್ರೆ ಆವರೇಜ್ ವ್ಯಾಲ್ಯೂ ಬಂದ್ಬಿಡುತ್ತೆ. ಸೊ ನಿಮಗೆ 5 ಮಾರ್ಕ್ಸ್ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೇಳೋ ಚಾನ್ಸಸ್ ಇರುತ್ತದೆ. ಅವಾಗ ಫೈಂಡ್ ಆವರೇಜ್ ವ್ಯಾಲ್ಯೂ ಆಫ್ ಕರೆಂಟ್ ಅಂದ್ರೆ ಫಸ್ಟ್ ಲೆಟ್ ಅಸ್ ಫೈಂಡ್ ಔಟ್ ಇಂಪೆಡೆನ್ಸ್ ಮಾಡ್ಕೊಂಡ್ಬಿಡ್ಬೇಕು. ಸೊ ಇಂಪೆಡೆನ್ಸ್ ಮಾಡೋಕ್ಕಿಂತ ಮುಂಚೆ ಇಂಡಕ್ಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್, ಕೆಪಾಸಿಟಿವ್ ರಿಯಾಕ್ಟೆನ್ಸ್ ಎಲ್ಲ ಮಾಡ್ಕೋಬೇಕು. ಅಂಡ್ XL XC ಮಾಡಿದ್ಮೇಲೆ Z ಯು ಹ್ಯಾವ್ ಟು ಫೈಂಡ್ ಔಟ್. ಆಫ್ಟರ್ ಫೈಂಡಿಂಗ್ ದ Z ವ್ಯಾಲ್ಯೂ ಕರೆಂಟ್ ಮಾಡ್ಕೋಬೇಕು. ಕರೆಂಟ್ ಬಂದಿದ್ದಾದ್ಮೇಲೆ I0 ಯು ಕ್ಯಾನ್ ಫೈಂಡ್ ಔಟ್, ರೂಟ್ 2 into IRMS. ಆಯ್ತಾ? ಆಫ್ಟರ್ ಫೈಂಡಿಂಗ್ I0, IM or I average we can find out 2 by pi I0. I0 ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ಕೊಂಡ್ರೆ IM ವ್ಯಾಲ್ಯೂ ಬರುತ್ತೆ. ಓಕೆ ಮಕ್ಕಳ? ಸೊ ಈ ತರ ನಿಮಗೆ ಪ್ರಾಬ್ಲಮ್ಸ್ ಕೂಡ ಸಾಕಷ್ಟು ಬರೋ ಚಾನ್ಸಸ್ ಇದರಲ್ಲಿ ಇರುತ್ತೆ. ಓಕೆ 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 let me stop here. Okay, we shall see in the next video other components in this chapter. Thank you.